All right, today, guys, we'll be solving two-step equations with integers. And as always, the goal is to find the value for the variable that is going to make the equation true. How do we reach this goal? We reach this goal by isolating the variable. And we isolate the variable using inverse operations. So, as always, the inverse or opposite, because that's what inverse means, of addition is subtraction, and the opposite or inverse of multiplication is division. Sorry, I can't find a real nice division sign, but division. So, we'll look at a couple of different examples, and we're going to solve the equations and use substitution to check the solution. All right, so 6x plus 8 is equal to 50. The goal is to isolate the variable. So I look and I ask myself, what is happening to the variable? It's being multiplied by 6 and 8 is being added to it. So that's going to tell me that I'm going to use more than one inverse operation to isolate this variable. The first thing I want to do is remove the constant. Remember, the constant is the number that stands alone, not attached to anything, just a solo dolo number. So over here with this x is a positive 8. Well, I'm going to use inverse operations to remove that positive 8 because I want everything on the other side of the equation and the variable by itself. So the inverse operation of adding 8 is subtracting 8. And if I subtract 8 from one side, I must subtract it from the other side. Well, I did nothing to the 6x, so I'll bring it down. Well, positive 8 and negative 8, they are opposites. Therefore, they're going to cancel each other out. And I am left with my equal sign, and 50 minus 8 is 42. Remember, the goal is to still solve for x. I want to isolate x. So now what's happening to it? 6 is being multiplied to it. That's letting me know that it's a coefficient because it's directly in front of the x. So what is the opposite of multiplying 6? It's dividing 6. And if I divide 6 from one side of the equation, I must divide 6 from the other side. Well, what happens when we divide 6 by 6? It cancels out. And I'm just simply left with x. And 42 divided by 6 is 7. Like always, we can use substitution to check ourselves, and this is what I mean. My original equation is 6x plus 8 is equal to 50. Well, we said that x was equal to 7. Therefore, I can take out x and substitute it with 7 to see if I get that answer. Order operation says multiplication first. So 42 plus 8. Yeah, 50 is equal to 50. Therefore, my solution is correct and my equation stayed balanced. So we look at our next example. 2n minus 5 is equal to 11. Remembering that the goal is to isolate the variable. Well, what's happening to the variable? It's being multiplied by 2 and 5 is being subtracted from it. So first things first, I don't want this constant over here. So I need to remove it so it can move to the other side. So the opposite of subtracting the constant is adding it. But if I add it to one side to keep the balanced equation, keep the equation balanced, I must add it to the other side. Well, I did nothing to 2n, so it just comes along for the ride. Minus 5 and plus 5, they're opposites, so they're going to cancel out. And 11 plus 5 is 16. Well, I'm still trying to isolate n. So I need to do the inverse operation of multiplying n because that 2 is being multiplied to n. So the opposite of multiplying 2 is dividing it. And if I divide 2 from one side, I must divide 2 from the other side. Well, what happens to my 2's? They cancel out, and I'm simply left with n is equal to 8. And we're going to use substitution to check our answer. 2n minus 5 is equal to 11. Well, what did we say n was equal to? 8. So 16 minus 5 is equal to 11. And so 11 equals 11. Therefore, the equation is balanced and the answer is n is equal to 8. We're going to look at some situations where my answer could be, where I have negatives in front of my variable. So 13 is equal to negative 4k plus 9. Looks a little different, but it's still the same. The object is to still isolate the variable. So what's happening to the variable is being multiplied to negative 4 and 9 is being added to it. So what I want to do is remove this constant. So what's the opposite of adding 9? The inverse of adding 9. Subtracting 9. Notice I didn't subtract 9 from 4k. I can't. They're not like terms. The only thing I can subtract a constant from is another constant. So 13 minus 9 is 4. I did nothing to negative 4k, so I'm going to bring negative 4k down. And positive 9 and negative 9 are opposites, so they cancel out. Well, k is still not isolated. So it's being multiplied to negative 4. The opposite of multiplying negative 4 is dividing negative 4. And if I divide from one side, as always, must divide from the other side. 4 divided by negative 4 gives me a negative 1. Well, this negative 4's cancel out, and I'm left with k. So k is equal to negative 1. But as always, we're going to double check ourselves just to make sure. So my original equation was 13 is equal to negative 4k plus 9. Well, we said k was equal to negative 1. So I can substitute it in for k, see if it's true. Negative 4 times negative 1 is a positive 4. And 4 plus 9 is 13. So yes, k being negative 1 makes the equation true. All right, and our last example. Negative 8 minus x is equal to 24. So I want to isolate the variable x. So what's happening to it? It's being multiplied by a negative 1. Remember, if it's not a number in front of the variable, it's an imaginary number there. But that minus sign makes it negative. So it's being multiplied to a negative 1, and negative 8 is being subtracted from it. So I want to isolate the variable by removing this constant first. The opposite of subtracting 8 is adding 8. And if I add 8 to one side, I must add it to the other side, making sure that I'm combining my like terms. Well, negative 8 and positive 8 are opposites. I did nothing to my negative 1x, and 24 plus 8 is 32. Now, the goal is to still isolate x. It's not isolated if it is a negative in front of it. So, negative 1 is being multiplied to x. The opposite of multiplying negative x is dividing negative x. The opposite, of multiplying a negative 1 to x is dividing a negative 1 from x. And if I divide negative 1 from one side, I must divide it from the other side. These negatives cancel out, and I'm left with x is equal to a negative 32. So let's check ourselves. The equation was negative 8 minus x is equal to 24. Well, we said that x was equal to negative 32. Notice I didn't change my minus sign. All I did was take out x and put what it was worth. So negative times a negative 32 gives me a positive 32. And negative 8 plus 32 gives me 24. And yes, 24 is equal to 24.